Hello, everyone, and welcome to the Precision Pays Off, Integrated Nutrient Management with Foliar, Multi-Nutrient, and Biostimulant Fertilizers webinar, presented by ICL. This discussion will explore how to boost crop performance through integrated nutrient management. I'm Hillary Wynn, the Custom Content Manager for Meister Media Worldwide, publisher of Crop Life magazine, and I'll be moderating this webinar. This webinar has been approved for 0.5 CEU credit for nutrient management from CCA. To receive credit, you must watch the entire webinar. If you've attended our webinars before, this process is a bit different, so please take note. An attendance poll will be sent out at some point during the webinar, and you must respond to receive credit. If you respond once the webinar is finished, you will receive an email with the QR code for reporting your credit. You simply scan the QR code and submit it. Please do not close your web browser before the webinar has ended completely, or you will not receive the email with the QR code. This is also for the viewers watching the archived webinar. Now, I'd like to go ahead and introduce our speakers, Dr. Eduardo Concilier and Christi Fallon. Eduardo is a global biostimulant specialist agronomist at ICL with 6 years of experience in biostimulants and folio fertilizers in South America. He specializes in biostimulants and focuses on product development and positioning in relation to crop needs and environmental conditions. Christi is an agronomy technical sales manager for the Pacific Northwest and California at ICL. She has more than 25 years of experience, including roles in university extension, plant nutrition, and crop protection. Welcome, Eduardo and Christi. At this point, I will go ahead and turn the webinar over to our speakers.
Well, today, I'd like for us to think about the fact that every gram of soil may contain microorganisms, up to 10,000 species of microorganisms, and typically millions of microbial cells. So the other fact to think about is that plants normally are only composed of about 4% of the mineral nutrients that come into play. So let's explore today how we can be more precise and how we can think about things that we can do for healthier and more productive crops and soils. So when we look at this diagram that's here, we can look at it and we can think, well, what pieces to the puzzle can we look at and how can we be more precise? Typically, if we look at just the fertility, the nutrient aspect that comes with it, then we're missing a lot of the pieces to the puzzle. So we also have to look at what the roots are like, how many exudates are coming, what are the relationships in the rhizosphere, what are the microflora doing, how are we doing as far as having nutrients go back and forth within the cell, what sort of regulatory controls, plant growth regulators are going on. You can see then we look at this and we think there is a whole system that we can be looking at, not just the nutrients. And so how can we maximize the productivity? How can we maximize the nutrient use efficiency and the assimilation and the utilization for our crops, and make sure that we're looking at healthy soils and a productive future? So we know that we can look at integrated nutrient management, and we're used to doing that, but how do we incorporate effectively the plant physiological process along with that? So here's a few tools that are listed for precise management. And we think about the importance of that root zone right next to the rhizosphere, getting the pH where it needs to be. A lot of our soils we have that are higher pH, we have to acidify them for higher nutrient use efficiency. So we're going to talk a little bit more about that today and how we can be more precise with our fertigation and our soil root interactions. We won't talk about the soil wetting pattern and reducing losses and controlled release fertilizers intensely, but remember that those are pieces to the puzzle. The other ones that we will talk about are polysulphate for a sustained release fertilizer that's a multi-nutrient, giving us new opportunities and innovations that we can utilize, as well as biostimulants and their connectivity with plant physiology, and foliar nutrition along with biostimulants and how those would come into play. So we're all familiar with the 4 R's, the right source, right rate, right time, right place that we've utilized in the past as far as our fertility and our nutrient aspects. But then we start taking it to the next level of the preciseness of it and enhancing our nutrient use efficiency. We want to do that because we don't want to have what we have here on the bottom with environmental contamination, lower crop yields, higher soil emissions, and going up or going down and leaching. And we also need to think about what we can do as far as reducing our carbon footprint in this environment that we are operating in. And so the things that we're going to focus on today would be then the reasons for low nutrient use efficiency will be more related to the soil reactions and the plant status. The weather condition management practices, we have to work within those, but not the focus for today's webinar. So as we start thinking about the right source and what we could do, we also need to think about the time and the place. But depending on what product we choose there and at what timing we're going to do it, then we're obviously going to vary our rate as far as what we would choose. So it'd be important to think about the fertilizer that you can utilize that will maximize what you need based on the crop and growth stages and what nutrients those crops need to maximize their productivity. When we look at a few of the examples that we're going to talk about today, because that's some of the ones that we have some data on, is looking at the Agrolution pH low products where you can actually acidify the soil in that rhizosphere. So when we think about acidifying it, we're not talking about major acidification. We're talking about high pH soils that need to be reduced down so that we can increase our nutrient use efficiency for like phosphorus, for example, and a lot of our other micronutrients. In addition to that, we need to think about when we have poor water quality, what can we do? What source of products? What's the compatibility? How can we not have buildup in those irrigation lines so that we can maximize both our water flow and our nutrient flow and our nutrient uptake? So those are definitely pieces to the puzzle for us to consider as well. And think about the compatibility for how they're going to work with other sources. So why would we care about being more precise for the acidifying within the root zone and thinking about the source and the placement as far as putting it where the plants need it? Because then we can start not only looking at enhancements to the crop yield, but then we can also look at reducing, for example, 2 to 4 times the amount of phosphorus that we would have to utilize. So then we can look at the environmental impacts that would have in a positive way. We'll look at one of the yields that we can see too, but as we increase our nutrient use efficiency, our nutrient assimilation, our access to those within the root zone, then we can increase our yield potential. And when we need additional calcium, we need to think about sources there or potassium that can reach those so that we can have high quality productive vegetables and fruit. So this example showcases for you the preciseness and the nutrient use efficiency that can come with it. We have, if you look down on the bottom, you can see that 4 gallons per acre of 1034O would supply 15.8 pounds of P2O5. Then if you look at a source, in this case, we're utilizing the Agrolution pH low, 12 pounds of that provides 5.4 pounds of P2O5. So we were actually able to increase the crop yield with 3 times less phosphorus that we were having to put on as far as putting it in for fertigation into that plant. So this is where the preciseness combined with understanding what we need from a nutrient use efficiency in the soils will help us with being able to maximize that crop yield. So the additional piece of the puzzle would be, let's look at that of the pH and say, what does it do for the phosphorus and the potassium? And we see in this case that when we fertilized in a precise manner along the root zone of the orchard of the pears, 9 times we were putting on 36 pounds of P2O5 per acre, and we actually should have, by what we typically look at for research-based, there's always going to be variability based on your cation exchange capacity and your texture, as far as how much nutrients or how much your parts per million is going to change. But in this case, it would have been about 2 parts per million that the soil would have increased from the 36 pounds of P2O5 and 3 parts per million for the potassium. So if we think about it in this case, we were actually able to double those levels. And then on the calcium and the magnesium side, we actually reduced with the pH low, we reduced the amount that was in the soil. So it was more that was being taken up by the plant in that case. So how does that transcend? What difference does it make? We've looked at the soil piece and what it did there. So did it really make a difference? Was putting that smaller amount in going to hurt us or was going to help us? And in this case, you see here where as we do that, and we've seen this multiple times in multiple different crops, where we actually have increased the yield potential that comes when we get the right nutrient at the right place and the right source for helping us with having the plant not only take it up, but assimilate it well at the proper timing. An additional thing that we can think about for enhancing that nutrient use efficiency and being able to look at the soil and what we can do that will help the plant would be looking here. If we look at the kind of the teal bar, we can see that polysulphate compared to potassium chloride or sulfate of potash, we have more that's taken up into the plant, and we also have more that's left in the soil and less that's leached. So as we can think about sources that help us with doing that and winning on multiple fronts for both the crops and the soils and the environment, then we want to explore those. So polysulphate has actually 4 different nutrients in it. One of those is sulfur. As we've done a better job at not having as much atmospheric sulfur, we actually need to start adding sulfur in. We need to make sure that we're balancing the nitrogen to sulfur ratio so that we can get better nitrogen use efficiency, better photosynthesis, better crop yield. And then we need to think, as the previous graph showed, about having less leaching, more residual for the crop. And we also want to have a sustained or a gradual release so that it's matching crop uptake. So we'll look at some graphs that will explore that. The other piece to the puzzle is trying to find alternatives for both organic and conventional agricultural production. And so polysulphate is one option that is organic certified. So we use it on both fronts. The low carbon footprint is actually 0.0029 per kilogram of CO2 equivalent. So very, very small carbon footprint, natural mineral that's merely crushed and then distributed out worldwide. And then the other piece to the puzzle is what can we do to help with overall plant health and how can we utilize nutrition, soil benefits to help us with that plant health. So this is a tool that we can utilize for that. So the polysulphate, you can see here is a mix, a natural mineral. You can see the pieces of it there on the right-hand side. It does contain sulfur, potassium, magnesium, and calcium, all in the sulfate form, so it's very readily taken up by the plants. Another piece to the puzzle would be looking at the preciseness of it and what should or shouldn't we do. This particular source has a low chloride, so it can actually be utilized right next to the plants without hurting the roots in a negative manner. So as we think about nutrient use efficiency and the practicalness of it, anytime that we can, like this picture here, anytime that we can build the root structure, then we can be able to increase the nutrient and the water uptake and the assimilation. So then we can increase the nutrient use efficiency. So even though polysulphate did not have nitrogen and phosphorus in it, there was an overall increase of 34 to 31% on phosphorus and 36% on the nitrogen. And then we also have the potassium use. So thinking about innovative ways for us to bring these tools into practice. So then we think here, this graph on the right-hand side, you can see the number one is the sulfate that's released from ammonium sulfate, or SOP. The yellow line, the number two, is the sulfate that's released from polysulphate. And the number three is the sulfate that the crop needs. So whenever we can match and do a sustained release of a product that's matching crop yield or crop uptake, then that's a good thing. And that's how we can have less losses and higher nutrient use efficiency. So if we look at a couple examples as far as what we can do and pull them into play, and how does it help for crop yield and the benefits of the quality. In this case, we look at the Agriform is a controlled release fertilizer. So that's that first line. The second two lines are combining either 150 pounds of polysulphate or 300 pounds of polysulphate. So as we follow the year through, we see that the plant health aspect has continued on, where you see that one for May 18th, that the yield is still staying there. We look at the yield for the season, and we can see that combination with the polysulphate was helping us for being able to get higher yield potential, better overall health. And this was in a year when we definitely had inclement weather that had definitely reduced our yield potential down. So then as we apply these precise innovative solutions and we integrate multi-nutrients in, we need to also look at what the quality piece is, and the desiccation losses in this case going down. So that's a benefit economically for the grower. And then we look at the botrytis or the disease and the desiccation loss going down as well when we add in the 300 pounds of polysulphate. So again, we do have to find the right rate and the right source that's going to work for us. In this case, this was a polysulphate trial in North Carolina on a very sandy soil, and notice at number 6 that actually the taste was increased, the taste score. So, we don't always think about that, but that's an important piece to the puzzle as we're selling product and we're not having waste, and we're being able to utilize products that are going to get sold and eaten and all of us to enjoy. So in that sandy soil, the nitrogen for North Carolina, the nitrogen typically decreases underneath the plastic, and they have challenges with getting adequate nitrogen there, not having losses. So the polysulphate, when they put that on, they were actually able to reduce the amount of nitrogen in the soil, and they could apply lower amounts of the full spectrum fertilizer. And then they were getting all of their sulfur, calcium, and magnesium and potassium from the polysulphate. Here's another example with a pepper trial. And so we look at the total nutrients that were applied during the season is on the right-hand side. We have the grower standard a low fertigation and then taking that low fertigation and adding to it either 250 or 500 pounds per acre of polysulphate, and then a high fertigation or a full fertigation. So sometimes we think we are going to be really precise with the fertigation, and that's the way to go, which can be true. But what if we have too much precipitation and we can't get in there and fertigate, and we don't want to put more water on or leach nutrients out? Or in this case, can we go with a little bit less fertigation, and can we combine a multi-nutrient solution in there with the polysulphate to help us? So, you look at then that treatment 3 and 4, we see that the total yield per acre with the polysulphate was increased compared to the grower standard. And the low fertigation was the number 2. We see that the marketable peppers, as far as their size, and the jumbos and the large, where we can get a premium price, were increased as well. So in this case, more nutrients in the full fertigation did not give us as good of a marketable yield. And then when we think about the precision of that and how that impacts us and the economics of it, we see here that when we look at the gross return, that those controlled release fertilizer in combination with the polysulphate increased our economic return and our bushels per acre. And if you look at the change on the right, we actually were able to increase 11 and 12% above the grower standard, with the polysulphate being the only change that we put into that puzzle. So again, let's think about the things that we can do and how we can utilize them to be more effective for our soil and our crops. One other example on the preciseness I want to share with you on polysulphate is with Honeycrisp apples, we have a huge challenge in making sure that we've got adequate supply of calcium that is going into the plant, that we have it at the right time, and that we can do that effectively. It's challenging. So, and especially with this variety, with the Honeycrisp. And it's economically, there's a lot of advantages to the Honeycrisp, but if we can get rid of the bitter pit. So we were more precise, the grower spent the time and the money to apply 150 pounds of polysulphate per acre at tight cluster and again at cell expansion. And by looking at that extra time and effort and the precision that came with it, they were actually able to increase from 83 fruit per tree to 97 fruit per tree and 170 bushels per acre. So the yield piece, that was better from that standpoint. So we were able to increase the crop yield. Now, when we start looking here, we have a 9% increase, a little over 9% increase in the good fruit that does not have the bitter pit. So that's definitely a very positive economic benefit and good for the environment, because we're not wasting fertilizer, we're not wasting crops, we're being able to get more fruit out and utilized by all of us. So we can start looking at it as a sustainable option that we can utilize. So I've shared a little bit with you about the aspects of the nutritional piece to the puzzle, and I'm actually going to turn it over to Eduardo to take you a little deeper.
Christi, for the great words on the alternatives of improving nutrient management. And I like how you put the 4 R's concept, because despite me going to cover some biostimulant and other physiological strategies, the basic nutrition and the soil fertility is the basis, and it's what I love to. And the 4 R's concept goes in line with a good agronomic practices and good management to get great yields in the field. So you covered fairly well some tips on the good source. You presented some alternative sources. You presented about timing of application, all of that precision, bringing it into higher yields. But despite us being taught and through many decades of learning, we learned to calculate and diagnose and recommend very well how many pounds per acre of a certain nutrient, of a certain fertilizer we need to meet the crop demand. But all of that took us so far in terms of yield and modern agriculture, it's still only 4% of the total plant composition. The rest of it is carbon, hydrogen, oxygen that comes from the air, comes from the water, and it has great help from the physiological process for acquisition and assimilation. So all of that, the machinery that builds up the plant using those elements is the plant physiology. And the fertilizers that you mentioned that uses the 4R strategies, they are responsible for keeping the supply of nutrients. But we want to take it further on managing the plant physiology to make the overall metabolism more efficient. And that's what biostimulants do. Biostimulants is rather recent and taking more and more popularity recently. And those are ways that we have to manage crops to improve other processes, those other than the nutrients themselves, or to improve the nutritional processes beyond what fertilizers are capable to. So that's why I bring this a bit of a provocation. It's not exactly a consolidated terms in of degraded nutrient management, but I want to put here the biostimulants as a next step after by nutrient source, because the fertilizers, they will provide available nutrients to the soil more or less efficiently according to the source, according to the 4Rs concept. But big mistake is when in agronomy school, or even us as a basic understanding, we think that soil provides plant with nutrients. That is not true. Soil only holds nutrients. The plant needs to go and get it. And by go and get it, I mean the acquisition of the nutrient from the soil and the use of it. And that, from that, then the crop starts taking an important part on the nutrient use, and that's what I put here, plant morphology and plant physiology. That's where the biostimulant goes, to change root morphology, root growth, in improving the crop's foraging capacity and improving the physiological processes that will make their use more efficient or more balanced. We're going to be discussing soon here on how we should be looking beyond the pounds per acre. So when we think of the nutrients and the plant physiology, what is the reason that we apply nutrients to plants? It is to make sure we supply what it needs to keep growth and all the physiological processes active. So that's what the fertilizers and the nutrients will do. The biostimulants, they will enhance further this physiological capacity. And more than that, you started this webinar mentioning how we can have more than 10,000 species of microbials per gram, more than millions of cells per gram of soils per soil. And in large, that intrinsic microbial association with plant roots have the capability to provide plants not only with more nutrients, but to keep a healthier growth and even to stimulate growth, supplying even phytohormones, modulating the interaction that the plant have with soil. So those additional pinpointed addition of elements, they can help the microbial life thrive in the soil and to improve even further the nutrient use efficiency. And that's what we're going to start talking about on this slide here. On the left-hand side, you can see an illustration of rhizosphere processes associated with soil fertility and nutrient acquisition. You can see here on the bottom left side on the green box here, while several nutrients like nitrogen, phosphates, potassium, they will typically be uptaken to a distance from 2 to no more than 4 millimeters away from the roots, meaning that the root must get closer to all the nutrients in the soil, and not only the elements that we provide as a fertilizer, but the whole soil volume. meaning that the plant must explore the whole soil profile in terms of depth, either horizontally and vertically. And when you think of, okay, we need to provide ways for the roots to grow more, I'm not thinking about root interception, because we know we may acquire nutrients through diffusion, mass flow, and root interception. We're not gonna get more root growth and increase root interception. No, even for diffusion to take place, the roots need to be closer to the nutrients, especially diffusion. But also, mass flow also have their limits. You can see here on this image more than 4 millimeters of distance, but it's still, when you think of the soy and row crops, that you would put row crops several inches away from each row, you still might not have accessed all the nutrients in the soil. So root growth and root morphology is crucial to good use of all the nutrients. But when we think it further, this picture here in the center, they are corn roots around tasseling. Those are the adventitious roots that you can see here, some substances dropping. Those are a bunch of sugars that are exudated by roots. Up to 30% of all the photosynthesis of the plant is exudated through the roots. And that carbon typically as different types of sugars and other signaling molecules. They help the plant to interact with the soil microbiome. So the plant selects and propagates microbials that will help their growth. Typically, they will help mineralize the nutrient sources. They might be mycorrhiza, helping to access more tightly bound nutrients such as phosphates, zinc, and so many other microbial interactions positive to the plant growth. So not only we can have increased root growth for increasing foraging capacity, but also boost these microbial interactions at the root zone. And we are capable of modulating that growth. And that's the beauty of it that we can use for crop management. You can see here on the left-hand side this trial where we have a control plant on the left-hand side, roots growing beautifully with their genetic potential. And you can add synthetic hormones such as indolacetic acid and improve that root growth or decrease root growth if the dose is not appropriate. But we also have natural biostimulant properties such as humic acid that you can see here on the right-hand side of the dark picture, that the roots will grow even further than their natural genetic potential. So that is a way that we can boost plant growth. And even on the right-hand side picture, you can see that even the mineral elements, they also deeply influence the root growth. So from this, I want to challenge all of you here to think of a different approach of nutrition, to go away from only thinking of the pounds per acre of nutrients that we recommend and think also about the physiological processes. If you see here on this figure, on the left-hand side in green, I have classic mineral nutrition. That's the typical concepts that we use. We evaluate nutritional status, think of the allocation, transport, uptake, and in the end of the day, we will test the soil, we will measure extraction, exportation, and recommend our fertilizer. So we are only looking at quantitative measurements, not really taking into account the physiological processes, the growth stages of the crop. So I want you guys to think of nutrition applied to plant physiology, to think of biochemical reactions and physiological processes. On the right-hand side here, I have several of those listed. For example, for soybeans, which is one very important crop in the US and worldwide, biological nitrogen fixation. You don't need to use any additional nitrogen to this crop, but you must have very active biological nitrogen fixation. And for that to take place, you need some elements that are beyond our traditional NPK fertilization. Moly plays a crucial role as part of nitrogenase. Cobalt also is used by the bacterium, not the plant, the bacterium, to perform nitrogen fixation. Nickel is also have been proven to play a role in this process. So I'm not thinking here only of measuring of how much kilogram of nitrogen I have on the leaf tissue, but I'm ensuring that the process that supplies that the nitrogen is active. We have a hard time testing soils and having reference values for nickel, moly, cobalt, and some other secondary elements. Sometimes it can even be smart to apply them in a preventive way. But the story doesn't stop here in biological nitrogen fixation that is important for soybeans. We should think of all the other crops and look at the physiological processes important for yield and development of each crop. Photosynthesis, of course, is going to happen in every crop, but look at the physiological processes inside photosynthesis. We need to ensure the trace elements level. We need to ensure that we don't have photooxidative stress, which is a type of stress that you could reduce through the use of biostimulants. We could boost biological tolerance to pathogens. That can be done through different types of elicitors. Even copper plays an important role of that. And why not silicon? Silicon, in certain books, are considered a biostimulant. So I'm challenging you to think beyond the pounds per acre of elements and thinking of the process. You need to ensure the physiological process is active, more than you need to ensure that a certain kilogram or certain pounds per acre of a nutrient is met. So let's continue it by looking at some alternatives and some practical examples on how we can do that. So we have one enhanced fertilizer formulation here that we have on the screen that we call it Biosdiamond. Besides the typical nutrition, and we often associate this product with traditional fertilizer products, it's very well applied together with starter fertilizer products. This product here will contain some organic molecules such as molasses that can provide an activation of soil microorganisms. So those soil microorganisms, they are highly adapted to the soil conditions, and they can help producing phytohormones that will finally come down to root development. And as such, humic substances also have this same effect of inducing root growth. They even are recorded in physiology books as auxin-like effect. The root senses the humic substances to the soil, and they respond to it in a manner that is similar to the effect of auxin. So that will get you greater root system and a great association with soil microorganisms when associated with molasses, increasing your crop's nutrient foraging capacity. Yeast extract is also a proprietary technology that we enhance even further the physiological processes. So we are thinking here of improving the physiological capacity of nutrient uptake by two means: physical, by exploring more inches of soil with roots closer to the elements, and proximity of roots to nutrients is fundamental for efficient uptake. But also, we are recruiting here the soil native microbials to help to extract more of those soil nutrients, such as mycorrhiza, such as the exudation of siderophorus, and so many other phosphate solubilizing bacteria that is native to the soil that can help us. So yes, the addition of external microbials is also a very great alternative on integrated nutrient management, such as nitrogen fixation, microbials, phosphate solubilizing products. But let's first take care of what we already have in the soil. And okay, so this enhanced formulation here will bring these benefits on the nutrient acquisition processes. And how do we measure it? One way that we, especially the microbial association and activity, that it's very difficult. So we have here some data that we have collected by evaluating 39 different sites, and we have evaluated the activity of 3 different enzymes. Those enzymes, they have been studied and they have been proven to be associated tightly with soil microbial equilibrium and a great management practice. Basically, when you have crop rotation, soil cover, no-till, all of those good management practices that improve the soil microbial activity, those correlates to those enzymes that are indicators of crop management quality. So, and we have seen across a wide range of crops and different soils that anywhere from 10 to 15, 16% of increase in activity of those enzymes. They have specific functions, each of those enzymes, but this is not the most important part. The most important part is that they are associated with quality of microbial activity and balance. Okay, let's be more practical. That's what it looks like in the field. On the left-hand side, a typical control plot. On the right-hand side, a crop that has been treated with those enhanced organic formulations that can induce better root growth. There is no problem at all with the root system on the left-hand side. But on the right-hand side here, you can definitely see that the crop has more conditions to use better than fertilizers that has been provided by it. But let's look at some data because, okay, it can be misleading to just look at pictures and see in one particular spot that you have more roots. So we have conducted a series of trials in the United States in several crops to validate this concept. And now I'm going to connect all of this with the precision that the Christi have mentioned with the Agrolution and pH low as a enhanced source of fertilizer going towards the 4R strategy. Treatment 1 is the control. And here we have a typical Midwest corn growing system in Wisconsin. Treatment 1 is the control. Treatment 2 is the typical ammonium polyphosphates at 3 gallons per acre. And treatment 3, always the blue bar, is when we have added BIOS diamond to it. So you can see here that we are increasing the technology level and the crops are responding very well. The two graphs here are two growing seasons, 2022 and 2023. You can see here that if you compare treatment 2, which is ammonium polyphosphates, against treatment 6, which is Agrolution pH low, an acidifying local application of phosphorus. And keep in mind, 12 pounds per acre will deliver much less phosphates per acre than the 3 gallons of ammonium polyphosphate. So even at lower rates of phosphates, we had an improving yield when you compare treatments 2 to 6 in both growth seasons. And the reason why we're saying that biostimulant is yet another tool in integrated nutrient management, even after looking at the 4Rs strategy and using the right source, right rate, very fine-tuned, precise nutrient management, we could improve the yields and the nutrient use efficiency even further with the addition of those specialty organic molecules to enhance the fertilizer use, with gains of around 4 to 6 bushels per acre in average of these 2 years of corn. We have repeated the same trial design in soybeans that we have here. Again, control, treatment 1, treatment 2, ammonium polyphosphate, number 3, the blue bars with BIOS. And now let's compare side by side. Treatment 4 with 5 here is Agrolution with and without BIOS. The same story repeats. We have ammonium polyphosphates compared 2 to 6. We increase yield with Agrolution pH low. And regardless of using a traditional nutrient source, such as ammonium polyphosphates, 2 against 3, we have improved the yield, but also using the best fine-tuned precision Agrolution pH low localized application, we could again see an improved in yield in both growth seasons, 22 and 23. And now we have here 4 different trials in corn, 2 in soybean, repeating the exact same trend. We didn't stop there. We did in potatoes. And again, same trial design and the same trend, meaning that it's a very consistent delivery in results. I'm not going to detail so much here, but we've been achieving very good yield increases with excellent return over investment here on those trials. But the important here is the concept. Precise application of the right source of nutrient that you can boost even further with the right physiological activator. And in this case here, we have used BIOS diamond. This happens all in the soil. But when I said that we should look further to the physiological process, It's not all about the roots. We also have foliar products. And here we are going to cover a few scenarios. For example, look at this case here on the grapes in Washington State. We had here a crop suffering a lot here in a high sunshine and drought. And after the application of some foliar formulations containing mostly mineral elements, how we could help the crop recover from those stresses. And the products used here, Nova Pulse and Nova Elevate, they have the formulations as in this table. And we are bringing here new alternatives or more balanced formulations, thinking beyond the traditional NPK, sulfur, calcium, magnesium formulations. Look at here how those two last, Nova Pulse and Nova Elevate, they have a high content of cobalt, moly, and nickel. Those are fundamental elements that are not commonly used in our crop system and our growing systems, and have been delivering excellent responses in a few cases. Nova Pulse is a formulation that has been initially designed for pulse crops to improve nitrogen fixation. So the balance of all of those nutrients together applied at early vegetative traits can deliver a great boost to the biological fixation. And that's what we have here in this first trial results. You see here control plots in soybeans in 2023, and then we applied in two different times of application, either at V4 or at flowering, both cases delivering 1.5 maybe to 5 bushels per acre, which is already significant. But both application at both stages delivered an even higher result. But there is always more to it that you could do. This other product here called Nova Finish, and I'll come back to the table here so you can have a look, that it's a NPK formulation with trace elements, especially rich in potassium. We all know that potassium is a great element to help boost the translocation of carbohydrates. Again, this small dose of foliar potassium is not gonna be the one able to substitute any soil applied potassium, either granular or liquid formulations at high dosages. But when applied at later crop development stages, when the root system is not as active anymore, we are finishing the translocation of the last reserves to the crop. This last boost of a few pounds per acre of potassium can significantly improve the translocation of carbohydrates and hence yield. So again, you see that we are looking at the physiological process of translocation of carbohydrates, not the overall potassium balance. That's what we want to bring to your attention, that there are more management alternatives that you can use to boost. And here, a less scientific trial. This is a side-by-side trial that we combine all the three products that I have mentioned so far. We have the grower practice. It's a simple insecticide, fungicide management. And the ICL foliar program, we added this Bios Diamond at the, as a starter, together with starter fertilizer, and then foliar applications of Pulse and Flow at flowering and grain filling respectively. And you can see here during the crop development that the right-hand side part of the field was applied with technology. And as the crop developed with here from 24 to 39 days after the treatment, we had significant improvement of the crop performance measured by the NDVI. And here you have a picture of it in the field. Right-hand side here, you can see it's clearly more yellow than the left-hand side. And why yellow? Yellow is the visual symptom of nitrogen deficiency. Sometimes you're gonna say, yeah, but it's normal that soybean leaves will go yellow before maturation. But maybe 1 week more that the crops stay greener will give you a significantly more time to get photosynthesis, accumulation of sugars, proteins, and become yield. Look at the nodules, significantly more nodules on the left-hand side root than the right-hand side. And that is provided by those nutrients that will act fundamentally at the nitrogen fixation. Again, we didn't, of course, we as in the R&D and product development process, we tested several dosages to see the best response, but we are not thinking of the overall balance. We are measuring the nitrogen fixation processes here, and that, of course, led to an increased yield here. We measured, we could make the counting of number of pods per plant, which increased from a range of 72 to 85 to 40 to 45 in the control treatment. So we have a lot of things to share. I would really love to share a lot more. And I'm going to come back once again, this slide, think outside the box, go beyond the typical pounds per acre, think of the plant physiology, and use alternative elements, not only mineral elements, but also organic and biostimulant products to boost each step of your crop development. So that in the end, what we want is to invest more on the groceries, more on the vitamins, more on the nutrition, invest less on the drugstore. We don't want so much pesticides. We don't want to be correcting the problems. We want healthy crops, and keep in mind that healthy plants come from healthy soils and balanced nutrition. And I'm going to give one last message here for Christi to conclude the presentation.
Yeah, so you guys, I really want to thank you for being with us and thinking about some of the details as we explore the things that we normally do. We pull it all into play. We think about the preciseness, the fertigation, the soils, the rhizosphere, and all of the things that we can do with different nutrient sources to increase our nutrient use efficiency. And we think about the plant physiological processes that we can do and how we can impact each of those. So we just encourage all of you to think about the things that we can do as we pull that together for the precision and integrating nutrient management and having productive and healthy and soils and have them be sustainable into the future. Hillary will take questions. If you have some questions for the group, and we do have our contact info up here if you guys have additional questions, so that you can do that afterwards.
Terrific. Thanks to both of you. So yeah, we do have some questions, so we'll just go ahead and dive in and try and get through as many as we can in the time we have left. How low a pH is the Agrolution products? Do we need special equipment / fittings to apply?
And the answer to that will be no, you don't need special fittings and everything to apply. You can have a variation with the Agrolution pH low products. The more concentrated you get them, the lower the pH is going to be. But most of the time we're looking at when we fertigate them being around 4 to 5 that we're looking at for the pH of them.
Okay. Do plants utilize molybdenum at all?
I can take that one.
Yes. Okay, go ahead, Eduardo.
Sorry, I interrupted you, Christi. Well, anyway, I'll take this. You take the next one. Yes, definitely. By the way, if the plants did not utilize molybdenum, they would die. Molybdenum has been proven as integral nutrient, and as such, it has passed the test of the essentiality of the 3 elements. That element must, be part of a physiological processes, and the plant does not complete their life cycle without it. For example, the plants cannot uptake nitrogen without molybdenum, because nitrate reductase, which is an enzyme used to uptake nitrogen, contains molybdenum in it. So if you don't have molybdenum, it's impossible to have high nitrogen use efficiency. So that's why I recommend whenever you're using high dosages of nitrogen, it's always a good idea to make sure you add some molybdenum to it.
Okay. For the Wisconsin corn and soybean trials, did you apply additional pea fertilizer other than the starter?
I did not conduct those trials myself, but I don't think that we applied anything additional other than those, unless it was across the board. Every treatment had exactly the same amount of phosphorus. So the only change that happened would be the changes as far as what we did with the treatments with the in-furrow applications.
All right, the next one's kind of a three-parter, so let's take the first part. Were NP/Ks balanced in all the treatments?
Yes.
What role do you think of bios played in enhancing crop yield?
I think I see here the question. The bios would typically enhance root development and association with microbial cells and microbial communities in the soil. So it probably acts through enhancing nutrient uptake. So it's an indirect yield effect by better nutrition. And also by increased root development. So it's very difficult to pinpoint which of those effects, because if you grow more roots, you also are able to uptake more water. If the root grows deeper and you have some, drought, or even in the rainfall is not well distributed, sometimes a small difference in water uptake can also be the reason for improved yield. But most cases, it comes down to nutrient uptake.
Okay, I'm going to go to the next one. Can certain fertilizers at too high of a ppm block the absorption of other fertilizers?
Most definitely. They all have to be in balance, and there has to be, if you have one get out of balance, then it can actually cause a deficiency with other nutrients. So it does have to be a balanced approach. And on that same note, with the molybdenum, we need the molybdenum, but it can be toxic. So it is a very precise nutrient that we want to be looking at managing.
All right. Can you elaborate any further on the mode of action of bios, on what microbial or plant functions get upregulated?
Eduardo, you're muted.
Sorry. Thank you. And just to be more clear, bios is actually a name of a range of products. And today in bios, we only talk specifically on bios diamond. But the mode of action of bios, we have evaluated this product in many different ways. When we talk about the soil biology, we tested it in two ways. One of those was through the enzyme levels in the soil. That is an indirect way to measure microbial activity. So the higher the microbial activity, typically you get higher levels of soil enzymatic activity. Another way that we tried, and just to come down again, that enzyme testing, it has the target of showing you the overall microbial activity. That's the target of that. And that is usually achieved with good management practices. You would achieve similar results with, cover crops, no-till, and several other of those good practices, organic fertilization. We also measured through metabar coding, which we measure the soil DNA, and from that we can calculate one index that we call Shannon-Weaver index, which is an index of diversity of soil microbials. And then I would tell you, we did typically find some increase in the diversity, but the product does not contain any microbial. So how can that happen that you increase diversity if you don't add any microbial? In fact, what happens is that some microbials that are very little active in very small populations, they can become more active, and then the testing method can actually start to capture them. So I don't think it's really that you have, it doesn't create any new microbes in the soil. It just awakens them and allows them to take a bigger part on the overall soil microbial population. So those are the modes of action. So activation of the soil microbes and direct activation of root development through the organic substances. So enhanced root growth.
All right, I think we can take one more. Do you think biostimulants work across all conditions, or do they work better in certain conditions, soil and environment?
Well, I can say from my perspective that I think that, sometimes we look for a silver bullet and you'd like to have one biostimulant that would do everything, but it's hard to find one that does everything. As we start looking down the line more, we find that we actually need to be a little bit more specific as we're developing products. Some of them are across the board, like the Biostimulants, where we can utilize it in a lot of different crops, but others may be to where, for example, let's say that we were looking at the color of fruit that we were wanting to enhance. So that would be a very specific purpose that we were looking at. So we can look at them on a very precise, integrative plant physiology, plant nutrition sort of aspect.
Okay, great. Lots of good questions. I want to thank everyone for attending today's webinar. I especially want to thank ICL for presenting it. And a special thanks to our speakers, Eduardo and Christi, for providing valuable information about boosting crop performance through integrated nutrient management. If you want to watch the webinar on demand or revisit certain parts, it will be archived and available at the same link you used to access it today. You will also receive an email reminder of the archive with the link tomorrow. Thank you again for joining us. This concludes the webinar.